All right, so you've learned about 2D lists, right? You know how to like put data in rows and columns.
Yeah, that's a great starting point.
It is, but now we're going to go a little deeper, make them, more powerful in our code.
Exactly. We're going to be looking at some examples from this awesome source material.
Oh, yeah, this one's packed with practical stuff.
Like, think about creating a grid, not just a static one, but one that can, like, change size dynamically.
And we can even make them interactive, have them like react to mouse clicks and change colors. It's going to be fun.
Totally. So think of it this way. We're kind of leveling up our 2D list game today.
Love that analogy. So let's dive in, shall we?
Let's do it.
You know, when you first start working with 2D lists, you might just set the size directly in the code, like maybe you're making a game board, and you decide, okay, I want this to be a 4x5 grid.
Yeah, that's a pretty common approach when you're first getting started.
But then what if you decide, you know what, actually a 3x4 grid would work much better?
That's when things can get a little messy.
Yeah, because then you have to go back and change not just the initial size, but like every single loop in your code that uses those numbers.
Totally. And that's exactly what the source material shows us.
Yeah, they start with app.dots equals makelist 4 or 5 to set up the grid.
And then they use range 4 and range 5 in their loops to actually go through the grid.
It's like, imagine planning a party for 20 people, and then suddenly you have to change it to 15.
Oh, I feel that. You'd have to go back and change all those invitations, all the seating arrangements.
It would be a nightmare.
And it's the same with code.
Yeah.
If you're constantly changing the grid size and then having to track down every single place of your code that's affected, it becomes really hard to manage.
It's inefficient and, like, error-prone.
Exactly. So what's the solution?
Variables. Instead of using those fixed numbers everywhere, we can define variables to hold our dimensions.
Right. So instead of 4 and 5, you could have something like app.rows3 and app.cols equals 4.
And then when you create your list, you just use makelist, app.rows, app.calls.
And the best part, you use those same variables, app.rows and app.cols, in your loops.
So instead of range 4, it becomes for row in range, app.rows.
And for the columns, it would be for col in range, app.cols.
It's so much cleaner.
It is. You're basically centralizing that information about the grid size, making it a single source of truth.
I love that single source of truth. It sounds so, like, official.
But it makes sense, right? If you need to change the grid size, you only have to change it in one place at the beginning of your code.
Exactly. No more hunting down every single loop. And everything else in your code that depends on those variables will just automatically update.
It's like, think about designing a level for a game. You might start with a certain size in mind, but as you test it out, you realize, this needs to be bigger, or maybe it's too cramped and it needs to be smaller.
With this approach, you can just tweak those two variables, app.rows and app.calls, and boom, the whole level resizes.
No need to go and manually adjust every single element, every enemy placement, every obstacle.
Huge time saver. But there's a catch, right?
Well, there's something we need to be mindful of, something the source material calls out as checkpoint 1.
Uh-oh, what's that?
Let's say you've done everything right. You've updated your make list to use those variables, so your grid is created with the correct dimensions.
Okay, sounds good so far.
But in another part of your code, maybe you have a function called, like, highlight call, and it still has that old condition, target call 5, from when it was a 4x5 grid.
I see where this is going.
If you then try to highlight column 4 in your new 3x4 grid,
Oh, no.
your code's going to freak out. It's going to try to access an element, index 4 in a row, that only has indices 0, 1, 2, and 3.
It's like trying to find the 5th book on a shelf that only has 4.
Exactly. It's going to cause a crash because you're essentially trying to reach into a part of memory that doesn't belong to your 2D list.
So we have to make sure that we're using those variables consistently throughout our code, right?
Absolutely. Consistency is key here. It's great to have that flexibility of dynamic dimensions, but you need to make sure those changes are reflected everywhere in your code.
Okay, that makes sense. Now, what if we're working with a 2D list, but we don't know its dimensions right away?
That's a great question. This happens a lot, especially when you're dealing with data that's coming from somewhere else, like a file or a database.
You don't know how many rows or columns it has, so how do you even start working with it?
Well, Python has a handy little function called len.
Len, like length.
Exactly. If you use len on your 2D list, let's say it's stored in a variable called L, then rows len LL will give you the total number of rows.
So it's counting how many inner lists there are within that main list.
Precisely. Each inner list represents a row in your 2D list.
No, okay, that makes sense. But what about the columns? How do we find out how many items are in each row?
For that, you can use len, L0. This will give you the length of the first row, which, in a well-structured 2D list, should be the same as the number of columns in every other row.
Oh, I see. So we're assuming that all the rows have the same number of columns.
Yeah, that's generally how 2D lists work. It's like a grid. Each row should have the same number of cells.
Right. So by using these two len calls, we can figure out the dimensions of any 2D list without having to know them beforehand.
And that makes your code much more adaptable because it can work with different 2D lists without you having to hard code those dimensions.
It's like instead of having a specific wrench for every single bolt, you have an adjustable wrench that can fit them all.
Exactly.
Okay, now let's talk about organizing our code. I know we've been talking about functions, but the source material specifically mentions using functions to actually create and return 2D lists.
Right. This is all about taking those steps we use to create a 2D list and packaging them into a neat little function.
So instead of having those steps scattered all over our code, we define them once in a function, and then we can just call that function whenever we need that specific type of 2D list.
It's like a recipe. You don't write out all the ingredients and instructions every time you want to bake a cake, right?
You have the recipe written down, and you just follow it.
Exactly. And in our case, the recipe is our function.
The source material gives us a great example with the makeColorsList function. Can you walk us through that?
Sure. So this function first creates an empty 2D list using our handy app.rows and app.cols variables.
So it's starting with a blank grid, the size of which we can control.
Yep. And then it has a list of color choices like red, blue, green, so on.
And this is where it gets interesting, right?
Yes. The function then goes through each position in that 2D list, row by row, column by column, and it randomly chooses a color from those color choices to put in that cell.
So it's like filling in that blank grid with random colors.
Exactly. And then at the end, it uses the return keyword to send that completed colorful 2D list back to whoever called the function.
So we can use this function to initialize our grid of colors at the beginning of our program, right?
That's what the code shows. App.colors equals makeColorsList.
So when the program starts, it calls this function, gets back a 2D list full of random colors, and stores that in the app.colors variable.
And now you have a 2D representation of your colorful grid ready to go.
But wait, it gets even better?
Oh yeah, the source material shows how we can use this function in a really dynamic way.
They call it inside the onKeyPress function, which runs every time a key is pressed.
And that means every time you hit a key, the makeColorsList function is called again.
So a brand new 2D list with random colors is generated, and then app.colors is updated with that new list.
Which means, on the screen, your grid changes colors.
So cool. But checkpoint 2 brings up an interesting point.
Yeah.
What if you call makeColorsList inside onKeyPress, but you don't assign the result back to app.colors?
Ooh, that's a good one.
What happens then?
Well, the function would still create that new 2D list, but since you're not capturing it, it's essentially lost.
It's like baking a cake but never taking it out of the oven.
Exactly. The app.colors variable would still hold the old list of colors, so the grid on the screen wouldn't change.
We're generating new colors, but we're not actually using them to update what the user sees.
That's a great way to put it. It highlights the importance of that assignment step, making sure you're connecting the output of the function back to the variable that's actually controlling what's displayed.
So we have to remember to write that line of code, app.colors equals makeColorsList, inside onKeyPress.
Absolutely. That's what makes the magic happen.
Okay, this is awesome. We can dynamically size our grids, randomly change their colors with functions. Now, let's talk about interactivity. What's this hit testing thing?
Hit testing is basically figuring out if the user, clicked or moved their mouse over a specific object on the screen.
So in our case, if they clicked on one of those circles in our grid?
Exactly. And since those circles are stored in a 2D list, we need a way to figure out which specific circle was clicked.
And that's where the onMouseMove function comes in, right?
Yep. This function runs every time the mouse cursor moves. And it uses those nested for loops we've been talking about to go through each circle in the grid.
And the key line here is dot equals app.so_call.
Right. So for each combination of row and call, the variable dot becomes a reference to one specific circle.
And then we have this line, if dot hits mouse x mouse y equals true. What's going on with dot hits?
So dot, representing our circle, has a built-in method called hits. This method takes the current mouse position, the mouse x and mouse y coordinates, as input.
Okay.
And it basically does some math to see if the mouse cursor is actually inside that circle's boundaries.
If it is, hits returns true, otherwise it's false.
Exactly. So the if condition is checking, is the mouse cursor currently over this specific circle?
And if it is, the example code does something cool. It draws red lines to highlight the row and column of that circle.
Yeah, it updates the position of these red lines, line for vertical and H-line for horizontal, based on the row and col of the circle that was hit.
And it sets their visible property to true so we can actually see them.
It's like, boom, now you know exactly which cell the mouse is over.
All right, checkpoint 3 adds a line, ... fill, gold inside that if block. What happens when we do that?
Well, now every time the mouse moves over a circle, that circle's fill color will change to gold.
So as you move the mouse around the grid, you're basically painting the circles gold.
But here's the thing. The code doesn't have a way to change the color back when the mouse moves away.
Oh, I see. So once a circle turns gold, it stays gold.
Exactly. It's a good example of how we need to think about those state changes in interactive programs.
If we want the circle to change back to its original color, we need to add more code to handle that.
For sure. You'd probably want to do something like, if the mouse is no longer over the circle, set its fill back to whatever it was before.
Makes sense. Okay, so to wrap things up, we've learned so much about making our 2D lists more powerful.
Totally. We've covered dynamic sizing, using functions to create and return 2D lists, and even hit testing to make them interactive.
It's like we've unlocked a whole new level of coding awesomeness.
I like that.
So for everyone listening, remember, using variables for your dimensions makes your code so much more flexible. Knowing how to find the dimensions of a 2D list using len lets you work with data even when you don't know its structure beforehand. And functions are amazing for organizing your code and creating dynamic content.
And those interactive elements, 2D lists are your best friend for that. You can create all sorts of cool, responsive experiences with them.
Speaking of cool experiences, any final thoughts for our listeners to ponder?
Well, think about this. How could you combine all these techniques we've talked about?
Oh, I like where this is going.
Imagine a grid of interactive tiles. Maybe when you hover over a tile, it not only changes color, but also changes shape. Or maybe plays a sound, and the sound is different depending on the tile's position in the grid.
You could even have grids that resize based on user input.
Exactly. There's so much you can do.
So go out there and experiment. Take what you've learned and build something awesome.
You got this.
All right, that's all for this deep dive. Until next time.